Welcome back to this lecture series on deep learning. In this lecture, we will discuss the topic recurrent neural networks and how it is going to be different from the ordinary neural network. These discussions we are going to see to it. This recurrent neural networks are a special class of neural networks designed to process sequential and time-dependent data. Unlike traditional networks, RNNs have the ability to remember past information, which makes them suitable for problems involving sequences such as text, speech, and signals. First, we'll see the overview of this artificial neural network. Just will quickly see to it. This artificial neural networks, all you know that it is inspired by the human. That means ANNs or computational models inspired by biological neurons. They simulate how the human brain processes information by passing signals through interconnected neurons. It consists of what? Hidden layer, and output layer. We have input layer, in between we have hidden layers, and this will be connected with the input is connected with the all the hidden layers. So the connections will be going like this. Everything will be connected, interconnected. This is input layer, this is hidden layer, and this is the output layer. So the input layer receives the input data. Hidden layer performs the computation. This will do the computation, and the output layer give the final result such as classification or prediction. This will be helpful for finding out whether this the input is what type of, and the classification. So it will be giving us the classification or predictions. And you know that the traditional artificial neural networks process fixed size input. That means ANNs require input of the same size each time and cannot handle varying length sequences naturally. That means if I am taking the two input output, my size will be 00011011. So first time if I am giving 00, next time also I should give 01. I cannot give 011 like that. So that only we are saying that the same size each time and cannot handle varying length sequences naturally. And they do not remember previous inputs. The once an input is processed, so these are all my input. So if I'm taking two input or AND gate or OR gate, once it is being processed, next I have to go for this 01. It will not be able to remember. So they do not remember previous inputs. Once an input is processed, it is forgotten. This lack of memory limits their ability to handle sequential data. Next, the limitations of the feed-forward networks are the feed-forward networks the first point, treat each input independently. As I have said, each input 00, 01, 10, and 11. So it will treat as input independently. Each input is processed separately without considering the past inputs. And there is no mechanism as there to store the past inputs. No mechanism, there is no memory unit to retain earlier data, making them unsuitable for sequences. And it is not suitable for time series, speech signal, and text and language processing. That means what? It will not, we cannot able to use it for this. Such data depends on order or and context, which for feed forward networks cannot capture. This leads to this the need for RNN. To overcome these limitations only, the recurrent neural networks were introduced. In order to that is overcome all these drawbacks in ANN, we are going for the recurrent neural networks. First, we should know what is recurrent neural network. It is shortly we are calling it as RNN, recurrent neural networks. The RNN RNN is designed for sequential data. RNN process data step by step, maintaining the order of inputs. It introduces the memory into networks, and RNN stores information from the previous steps using the internal memory. Previous steps influence current output data, and the current decision depends not only on the present input but also on the past inputs. And the order of data here it will matters. That means RNNs are effective when data sequence affects the meaning such as language. Next, the key idea of the RNNs. Here we have given two diagrams. The first figure shows that this is the RNN. This diagram shows the RNN with a loop. We can call it as a loop here because the hidden layer outputs are fed back to this layer. Another one more layer. This diagram shows the RNN cell with a looped arrow. There is arrow here. This we can call it as the looped arrow. The loop indicates that the output of the hidden layer is fed back to itself. Fed back to itself. So here it is there, fed back to itself. This I have, for our understanding, I have given the diagram like this. So this arrow represents what? Network remembers this feedback allows the network to remember information from previous steps. It represents the idea of memory inside the networks. That means what is the meaning for this is the RNN uses the past information while processing the current input. I have the input like this. This will be the feedback to the input means it will be keeping the past inputs while you are processing 0, 1. This diagram 2 represents the each individual we have taken over here. This is the ornan unfolded through the time. This diagram shows the same RNN cell. Same here it has been given no same RNN sequences, and it is expanded across the multiple time steps. Each block process one input sequence. Each block process the one input. So here if I have x1, x2, x3 up to xn, each cell will process the one step, one input in sequence x1, x2 up to xn. All time that is these all time steps share the same weights and processes, same steps and the same for all those things, the same steps will be followed. This means RNN process the sequence data step by step while carrying memory forward. Next, and so the key idea of RNN is to store past information using the hidden state through feedback connections and apply the same network repeatedly over time to process. Next, the key idea is loop has been given. The past information is used to better helps in better decision making. Next, the hidden state. If you are taking this we are calling it as the memory of RNN. The hidden state stores previous input information. It acts as the network's memory. It acts as the network's memory, and it is updated at every time step. As new input arrives, the hidden state changes and it is represented as HT. The notation HT means hidden state. This represents what? Hidden state. We can call it as hidden state. And time step, hidden state at time step. What is the time step we have taken? Time step T. And it combines the current and past previous. That means past means previous data. It merges present input with the past memory. It merges the present with past memory. Next, what is the working principle of RNN? We'll see. This in here, the input is given one element at a time. That means RNN processes sequences step by step, and the hidden states is updated using current input and past hidden input. And the model updates its memory continuously. and the output is generated at each step. That means RNN can give output after every input, and it repeats the repeat until sequence ends. The process continues for entire data sequence. So 00 01 10 11, like that it will be processing till the final data. And RNNs for the sequential data, and the sequential data has order. What is the order it has? The position of data elements matters. Example, if you are taking the text ECG and stock prices. So these are all my input data, and these data sets depends on time or sequence. RNN captures temporal dependency. It models the relationship across the time step effectively. And the applications of RNN are, it is used in the natural language processing, that means used for translation and text generation. Next, speech recognition. In this case, it processes the audio signals over time. So in this case, it is used for the text generation, translation and text generation. These are all main applications. And the time series forecasting means predicts future values based on the past tense. Say for example, the rain predictions, everything predicts the future values. Sorry, it predicts the future values. The exact application is the rain prediction. Future values based on past trends. And it is also used in the sentiment analysis. It analyzes the emotions from the text sequence. It analyzes the emotions from text sequences. And it is also used in the biomedical signal analysis. That means ECG and EEG. It captures the time-based patterns in health signals. And coming into the summary, RNN handles that is designed to handle sequential data. That means RNN handles sequence data effectively. They are designed for ordered data processing. They maintain memory using hidden states. Memory is the key feature of RNNs, and the feedbacks connections makes RNN unique. Feedback only it makes the RNN unique. This distinguishes from the traditional network, and it is useful in real world time dependent problems. And RNNs are widely used in the widely applied in languages. Mainly it is real world applications, like language mainly applied in language, that means natural language processing, signals, and forecasting, rain forecasting, etc. So many things are there. So these are all the summary of the RNN. Now we have seen the basic concepts of the introduction about RNN. The remaining things we'll discuss in detail in the next lecture. Hope everyone understood about the basic concepts of RNN. The remaining things we'll discuss in detail in the next lecture. Thank you.